In the field of artificial intelligence, particularly with large language models, the quality and diversity of training data are crucial for achieving high performance. This paper, titled QuaDMix, Quality Diversity Balanced Data Selection for Efficient LLM Pretraining, explores how to optimize these two aspects together rather than handling them separately. The authors, a team from ByteDance including researchers like Fengze Liu and Weidong Zhou, point out that existing studies often focus on quality filtering first and then adjust for diversity, but this misses the inherent trade-off between the two. For instance, prioritizing high-quality data might reduce diversity, while aiming for a broad mix could dilute overall quality. Given a fixed amount of training data, it's essential to evaluate not just the quality of each piece of data but also how it complements the entire dataset. To address this, the paper introduces a unified framework called QuaDMix. This system automatically optimizes the data distribution for pre-training LLMs by balancing quality and diversity. They start by proposing multiple criteria to measure data quality. These could include things like how well-formed the text is, its educational value, or its similarity to data used in fine-tuning models. At the same time, they use domain classification to assess diversity. This means categorizing data points into areas like health, education, or jobs, so they can understand the overall spread of topics. Once these measurements are in place, QuaDMix employs a parameterized data sampling function. This function calculates the probability of selecting each data point based on its quality scores and its contribution to diversity. Essentially, it's a smart way to decide how often a particular piece of data should be sampled during training, ensuring that the dataset isn't skewed too far in one direction. To make this process more efficient, the researchers conduct simulated experiments on smaller models. This helps them speed up the search for the best parameters in their framework. They draw inspiration from a method called RegMix and use a machine learning tool called LightGBM to fine-tune these parameters quickly. LightGBM is a gradient boosting framework that's great for handling complex optimizations without requiring massive computational resources. The paper's experiments demonstrate the effectiveness of QuaDMix across various models and datasets. They found that this approach leads to an average performance improvement of 7.2% on multiple benchmarks. This outperforms strategies that handle quality and diversity independently, underscoring the importance of balancing the two. Delving deeper into the introduction, the authors highlight how the efficiency of LLM pretraining is heavily influenced by the training corpus. Studies like those by Brown and colleagues in 2020, or Chowdhury in 2023, show that curating high-quality data can boost performance. Other research emphasizes data deduplication and diversification to avoid redundancy and ensure broad coverage. For example, works by Abbas and Tiryamala in 2023 discuss how balancing data across domains can enhance model capabilities. However, the paper identifies two major challenges in data selection. First, defining quality and diversity isn't straightforward. Quality might be measured by regular expressions for text structure, educational value, or even how closely the data resembles instruction-based tuning data. Diversity isn't just about uniform distribution. As seen in studies by Liu and Abbas, a more effective mix might involve strategic weighting of topics. The second challenge is the interplay between quality and diversity. As illustrated in Figure 1 of the paper, when you select only the top 5% of documents based on a quality classifier like FineWeb-Edu, the distribution shifts dramatically. Domains like health, jobs, and education become overrepresented compared to the original dataset. This shows that quality filters can introduce biases, and changing the data mixture affects overall quality since different domains have varying levels of high-quality content. With limited high-quality data available, there's an inevitable trade-off, making it impossible to optimize one without considering the other. To tackle these issues, QuaDMix takes a holistic approach. It applies several quality scorers and domain classifiers to every document in the training corpus. For quality, they aggregate scores from multiple sources to get a comprehensive view. For diversity, domain classification helps measure how well the data covers different areas. The core of QuaDMix is this parameterized sampling function, which determines the sampling probability for each document. It's designed to integrate both quality and diversity labels into a single formula. For example, The function might weigh a document's quality score against how underrepresented its domain is in the current dataset, ensuring that the final mix is balanced. In their methodology, the authors emphasize accelerating the parameter search. By running simulations on smaller models, they can test different configurations without the high costs of full-scale LLM training. Using light GBM, they model the relationships between parameters and performance outcomes, allowing for efficient optimization. The experimental results are compelling. Across diverse models and datasets, QuaDMix consistently shows improvements. This 7.2% average gain highlights how jointly optimizing quality and diversity leads to better outcomes than sequential or independent strategies. One key insight from the paper is that the choice of quality criteria directly impacts diversity. For instance, if a quality scorer favors certain types of text, it could unintentionally reduce the variety of domains. By contrast, QuaDMix's unified approach mitigates this by considering both factors simultaneously. The authors also note that high-quality data is often scarce, so decisions about data mixtures must account for this scarcity. Their framework provides a way to navigate these trade-offs, potentially making LLM pretraining more efficient and effective. In summary of their contributions, QuaDMix offers a practical solution to an ongoing challenge in AI research. By automating the balancing act between quality and diversity, it paves the way for more robust language models. The paper's findings encourage future work to explore similar integrated strategies for data curation.